Thank you, Craig, and thanks to Heartland for running such a wonderful conference. I always love it. There's been a question that's kind of bothered me for a long time, and I'm going to be addressing that today. Let me make sure I've got the right button here. Okay, there we go. I'll be talking about CO2 and the glacial periods of our long ice age. We're in an ice age, believe it or not. And Milankovitch versus Gore, there's no contest. You've seen this graph several times in one way or another. There is one line over here, the black line, which represents the atmospheric CO2 for the last 600 million years or so. The present is on the right. The temperature is represented by this blue line here, and goes in there and then comes down here. There's these long ice ages when we're in the arms of the Milky Way, according to Nir Shaviv, and those times in there when we're not in the arms of the Milky Way. Anyway, our last million years are down in here, but anyway, in there certainly is no correlation between CO2 and temperature, and here we've got 10 times as much CO2 in what's a very profound ice age back there around 450 million years ago. Our last million years, that's actually about 3 million years in there somewhere, but we have some data from ice cores on temperature and CO2, and here's Al Gore discovering a pattern. The CO2 and the temperature rise and fall together. Okay, now the question is, according to Al Gore, of course, the CO2 is causing the temperature to change, but he evidently didn't read the ICCC reports because they don't say any such thing. But anyway, the first principle of causality is that the cause has to come before the effect. I mean, well, if you believe in retroactive causality, how about a morning after pill for men, or committing posthumous suicide? Okay, the main cause of those long variations from the glacial periods to the interglacial have to do with the orbital parameters of the Earth. In particular, the tilt of the Earth's axis, which varies, the precession, that is, the axis goes this way around like that, with about a 26,000 year period, and the change in orbital shape from more circular to more elliptical. And those are the basic causes according to the ICCC, and they're called Milankovitch cycles after a Serbian mathematician. Okay, but there's a very good correlation then between the Milankovitch cycles, particularly the insolation, the amount of sunlight reaching greater than 65 degrees latitude, and the temperature and the concentration. So I'm going to represent those by M, T, and C. So I'm going to list some a priori possibilities here, of which you might find some worthy of a giggle. Sequence is the carbon dioxide concentration affects the Milankovitch cycles, which in turn affect the temperature. What? What? Another one is the carbon affects the temperature, which affects the Milankovitch cycles. Temperature affects the Milankovitch cycles, which affects the carbon concentration, etc. Now we have a couple more here. The Milankovitch cycles affect the carbon, which affects the temperature, or affect the temperature, which affects the carbon, or it's just totally accidental. Now, I think we can probably rule out the Milankovitch cycles as an effect. A cause, perhaps, certainly not an effect. So then we have Milankovitch cycles causing carbon to affect the temperature, or is the Milankovitch cycles causing the temperature to affect the carbon, and I really mean carbon dioxide concentration, or there could be some accidental correlation there. Now let us assume for the moment that CO2 is the cause. Okay, the question is, in those cycles where the CO2 and the temperature were going up and down, I would ask of Mr. Gore, where does the CO2 come from that caused the warming, and where did it go if it caused the cooling? And then how is that caused by the Milankovitch cycles? So where did it come from? Where did it go? And said differently, gee whiz, there was all that CO2, why didn't it keep the Earth warm? And then how was that caused by Milankovitch cycles? Well, there's an interesting paper that came out, I've emphasized 2014, this was published in Science, by Alfredo Martinez Garcia and others, called Iron Fertilization of the Sub-Antarctic Ocean During the Last Ice Age. You probably can't read that at the back of the room, because that's really not the important part. You can look it up. And they provide some rather interesting data. This is the main thing here. This is the age. Now, in this case, the present is on the left, and the past, that goes back 160,000 years, is on the right. And this is going back to the previous cooling that led to the last ice age, okay? These values here are, the top graph is carbon dioxide, the iron flux in black, and the delta N15. That's the variation in the nitrogen 15 isotope in globigerina boloids in red, alkenones in green, and the dust flux measured at EPICA, which is it's a test site, down here at the bottom. Okay, now, what they found and remarked upon was the fact that during this cooling, the iron was going up, and this thing is a little bit slow, the carbon dioxide was going down. Now, the essence of their argument is that when the iron was increasing, this is iron found in this is ocean bottom stuff. They're looking, they've done corings, okay? They found out the more dust there is and the more iron there is, the less CO2 there is, and they attribute it to the following phenomenon, that as the Earth cools down, there is more desertification in places like the Atacama Desert and the Kalahari Desert, I guess, and then the winds blow and they blow that dust out to sea. It has iron in it. The iron fertilizes the plant life out in the sea, and that sucks the CO2 out of the air. Wait for it. So the sequence looks like the following. First there's cooling, and then there's desertification, and they say peak glacial times and millennial cold events are characterized by increases in dust flux. Iron-bearing dust fertilizes the oceans. More phytoplankton consume more CO2. Atmospheric CO2 concentration goes down. Before, after. Okay? The cooling occurred first. The cooling preceded the reduction of CO2. The diminishing CO2 was not caused by cooling. Okay? Dealing cause and effect. Cause has to come before the effect. During the warming phase, again, we asked the question, which came first, the warming or the CO2? And what is the mechanism? According to Al Gore, CO2 increased because God said so, and then that heated up the Earth. go back to the same graph over here, but now we look at during the time of the previous warming, the iron concentration went down like a shot, and the CO2 concentration went up like a shot. In other words, the lack of iron fertilization was the cause for the increase in the CO2 concentration. And this paper says, you want me to read that to you? FB is foraminifera bound. That's delta 15 nitrogen and blah, 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 blah. That's written in pure academic style, but what it says is that when the earth warms, the decreasing iron fertilization leads to increasing CO2. Okay, the sequence works like this: the warming, greening of the deserts, less iron-bearing dust to fertilize the oceans, less CO2 consumption. The CO2 concentration increases because the oceans have got oceans of CO2. And again, the warming came before the CO2. Now, they've got an ice core there, and I've stretched out this scale. They've got a graph here. CO2 is in pink and the temperature is in blue. And believe it or not, on an edge like that, there's just no way to tell which came first. All you have to do is shift the scale down a bit or a little bit, because they don't start at zero. You can make it look like anything that you want to. But we will take a look at what some other people have had to say. From one paper in Science, they talk about CO2 concentrations increased 600 plus minus 400 years before or after the warming. There's that paper. And then there's another paper where I haven't bothered writing a quote, but they, again, they found about a few hundred year, lag between CO2 and temperature. But here's another paper that was written in 2013. We find no significant asynchrony between them, indicating that Antarctic temperature did not begin to rise hundreds of years before the concentration of CO2. All right, let's look at their data that they present. This is a whole bunch of data with a whole bunch of graphs, all on a time scale, going from 10,000 years on the left, or maybe 8,000 over there, to 22,000. So as you go to the right, you're going backward in time, and the present doesn't show because this is during the cooling phase. Now, they have three indicators of temperature up here. That is actually the inferred temperature. This one over here is the variations in deuterium concentration, and this one down here is the variations in oxygen-18, for which they infer the temperature. And these two things in here are both representative of carbon dioxide. This line in here indicates the concentration, and this line in here indicates the forcing, which goes with the logarithm of the concentration. And these numbers in here represent the lead or lag of the temperature coming before the CO2. So that a negative value means the CO2 increases come after the temperature changes. Okay. All right, so look at the numbers here. I just took these numbers off that previous chart. These are values where the CO2 lags. Those are the number of years they lag. Now there's two of these edges, and they're looking both at the CO2 concentration and the CO2 forcing. And over here, they've got four values where the temperature lags. And look at the numbers, 10 plus or minus 160, and so forth. Well, when you have an uncertainty that's greater than your value, that's not going to work. The average of the best data is something like 417 years. If you took the average of all the data, it's more like 150 years where the CO2 comes first. The temperature change comes first. But under no circumstances can you conclude that the CO2 came first. So the summary is that all evidence in the last million years or so says the variations in CO2 concentration have come after the temperature changes. And, okay, it's not to say that CO2 is not a greenhouse gas. We're not saying that. It just isn't enough to stave off the glacial periods. And my time has run out. And thank you very much for listening.